Hi everyone. I think everyone is good at there, and after long time again, I'm gonna start my YouTube channel. The reason behind it, some of my students were asking me uh, how to score 100% in physics, right? So here, I can strongly tell you that many of you people can answer all the descriptive questions. If you read the question once or twice in your physics textbook, you could think and you could revise the concept, you can answer them. Whereas coming to solving the problems, it is somewhat difficult to the few people to understand them well, right? So here I decided to do the series of my YouTube videos based on the problematic questions of particularly from 10th standard physics, right? In physical textbook there will be 12 lessons. In the 12 lessons, 6 lessons belongs to the physics and 6 belongs to the chemistry, right? So if it is possible, we'll discuss the chemistry also, right? First let me complete the physics part. In the physics there will be 6 lessons. In that 6 lessons you can answer all the questions, but what about numerical, right? So here if you wanna solve, maybe if your exam question, I mean if your examination paper is for 50 marks, in the 50 marks definitely 45 marks you will gain for easily can gain, not only yourself, everyone can gain easily 45 marks. Whereas coming to the least last 5 marks, they are difficult to achieve. I mean only the people who do smart work along with hard work, they can achieve them, right? So here my I want to put my effort to make you achieve those 5 marks also, then it will be completely you can achieve out of from the you can crack a physical science, right? So now here many of my students who are facing problem to solving the problem, they are asking to do the videos regarding problems to solve the physics from 10th standard, right? So now here first we'll take a heat lesson, right? So we'll take heat lesson, we'll discuss the problem, all the problems and how to solve them, the simplest way to solve. And I can tell you that if you once watch this video, you get a clarity how to solve the problems from the physics lesson, right? So I mean heat lesson, right? So now let's get started, right? So as I said, the first one, heat. The first one is heat, right? So coming to here, before entering into the solving of the problems and the numerical problems, let's discuss a few keywords. After discussing the few keywords and a few problems, a few formulas, right? After that we can solve the problems, right? The first one, let's see the definition of a temperature. A temperature in the sense the degrees of hotness or coldness of an object is called temperature. So I would like to tell you in Telugu also, because some of my Telugu students also are there, right? So now here temperature ante the degrees of hotness or coldness of an object is called temperature. అంటే ఒక ఆబ్జెక్ట్ ఎంత వేడిగా ఉంది లేదా ఎంత చల్లగా ఉంది అనేది మనకి టెంపరేచర్ చెబుతుంది, రైట్? సో ద SI యూనిట్స్ ఆఫ్ టెంపరేచర్ is Kelvin and CGS units of temperature is degree Celsius, right? So and you might know very well how to convert the temperature from degree Celsius to SI units, I mean kelvins, and Kelvin to degree Celsius, right? So here if you observe carefully, the 0 degree Kelvin also is called absolute zero temperature. The minimum temperature that we can measure is 0 degree Celsius. 0 Kelvin, sorry, not 0 degree Celsius. 0 Kelvin is the absolute temperature that we can measure, right? We can call it as a absolute zero temperature also. Okay na? So now here, okay, we'll end. I mean one more problem here, they may ask you that conversion of temperature, convert 20 degrees Celsius into Kelvin, right? Let us see first one, convert 20 degree Celsius into a Kelvin. So here when you want to convert it into kelvins, what you have to do is first you have to add 273, actually 273.15, but approximately we can take it as a 273, right? 20 plus 273, then it will be like that is equals to how many? 293 Kelvin, right? So how much it is? 293 kelvins. And like this they are very small questions, you can do it on your fingertips, right? So for example they will ask you 300 kelvins, convert 300 kelvins into degree Celsius, then what you have to do, you have to subtract a 273, right? So if you take a 273, then you will have here 7 and 9 to 2, yes, this is 27 degrees Celsius. 27 degrees Celsius if you convert the 300 Kelvin into degree Celsius, right? So these are very smallest problems in the heat lesson, and you can get it for 1 mark, right? Or you can directly objective type. If there are objective questions in that, they may ask you like this. The first simplest thing is the first step to solve the heat problems is converting of temperature, right? SI unit of temperature is Kelvin. CGS unit of temperature is degree Celsius, right? Here I told you, if you want to convert degree Celsius into kelvins, what you have to do, you have to add 273 plus 273, and if you convert kelvins to degree Celsius, then you have to subtract 273. That means 300 kelvins minus 273, then you will get the value in degree Celsius. Actually, not only degree Celsius and Kelvin scale, there are many scales in temperature, and you know that formula also. By using that formula, you can convert degree Celsius to Kelvin, Kelvin scale to degree Celsius, at the same time Fahrenheit to Kelvin, Kelvin to Fahrenheit, Ramer scale to Kelvin, Kelvin to Ramer scale. So I will display this formula here, you can see that, right? So this is very smallest thing for the 10th standard, right? So now let's enter into the next keyword about heat. We discussed about the temperature. Up to now we discussed about the temperature and conversion of the temperature. The next step is heat. Here you know very well the definition of heat. Heat is a form of energy that is transits always from hotter body to cooler body. What does it mean? When you keep contact two objects, one is hotter body and another one is cooler body, when you keep them in touch like a thermal contact, then what happens? Heat, it travels from hotter body to cooler body. Obviously hotter body will have high temperature and cooler body will have low temperature. Here the temperature shows the direction to the heat, right? So here heat always transfers from high temperature body to the low temperature body. This is the main definition of heat. It is a form of energy, right? So here the SI unit of heat is joule. A CGS unit of heat is 1 calorie. CGS unit of heat is calorie and SI unit of heat is joule. So now here, what is the meaning of calorie? For example, if you measure the physical quantity length, you will get 1 centimeters, meters, kilometers, right? We know that 1 meter, this is how much length it is, right? So he, in the same manner, what does mean 1 calorie of energy? 1 calorie of energy, right? Often when you eat biscuits, on the biscuit, if you eat this biscuit, you will get 900 kilocalories of energy, right? So first of all, let's see what is 1 calorie, right? So here the required heat energy to rise the temperature of 1 gram of water by 1 degree Celsius is called 1 calorie, right? So here you might get question. Let me repeat that once again. The required heat energy to rise the temperature of 1 gram of water by 1 degree Celsius is called 1 calorie. So you might get the doubt, why do we take only water? Why don't we take remaining substances? Here you know very well water available universally, right? In units and measurements, when we are learning units and measurements, you might listen that. So we have to select the substance to as a unit which is universally available. So water is the best solution, best substance which available to everyone, so that by considering water, we will calculate the calorie, right? Let's once again see. Just you take a bowl. Let me tell you a small example. You take the bowl. In a bowl, you take just 1 gram of water. You take 1 gram of water and measure its initial temperature. Just it's showing that 26 degrees Celsius. It's the initial temperature, right? So after this, you have to raise the temperature of this 26 degrees Celsius to 27 degrees Celsius. If you want to raise the temperature 26 degrees to one day, from 26 to 27 we are rising. That means we are rising only 1 degree Celsius, right? 1 unit we are rising. So to rise 1 unit, what we have to do? What we have to do? We have to give heat energy. If you give heat energy, then its temperature gets raised, isn't it? Right? So here that required heat energy to rise 1 degree Celsius of 1 gram of water is called 1 calorie, right? So here this is the SI CGS unit of heat. Here 1 calorie is equals to 4.186 joules. Joules are the units of heat in a SI system, right? So second basic problems which they may ask on this content, right? So coming to a next formula, well known formula, you know very well, right? So I can derive the equation, but you might already know this. If you want to make me, just comment me below, I'll derive that, right? So here next equation is Q is equals to Sm delta T. Sm delta T. This is the formula we use when a substance loses energy or gains energy. Here a Q in the sense heat energy that lost or gained by substance. S in the sense the specific heat of a substance. It's a constant for a substance, right? And next M in the sense mass of the substance. And next delta T in the sense temperature of the substance. So now here first Q is equals to Sm delta T. Based on this formula we are going to solve all the problems, right? First most thing is based on this we are going to derive one more formula also. That formula is the principle of method of mixtures. So here coming to the principle of method of mixtures, you know very well, I think so. If you have let me explain what is the principle of method of mixtures. Here when you keep in contact of two objects, one is hotter body and another one is cooler body. So obviously what will happen? Hotter body will lose the heat energy, cooler body will gain the heat energy. So here the heat energy lost by the hotter body will be equal to heat energy gained by the cooler body, right? Exactly, this is called principle of method of mixture. Based on this equation, this principle, we are going to solve many problems, right? So first thing they ask you, for example, let me give the question first, after I'll explain the content, right? So first of all they'll ask you that they'll give you 1 kg of water in one bucket which is at 40 degrees Celsius. In another bucket there is a half kg of water which is at 80 degrees Celsius. If I mix both of them, then what would be the final temperature, right? So let me explain this question in Telugu. So ఒక బకెట్లో 1 kg వాటర్ తీసుకున్నాం విచ్ ఈజ్ ఎట్ 40 degrees Celsius. ఇంకొక బకెట్లో ఇంకొక బీకర్లో హాఫ్ కేజీ ఆఫ్ 500 grams ఆఫ్ వాటర్ తీసుకున్నాం విచ్ ఈజ్ ఎట్ 80 degrees Celsius. ఈ రెండింటిని మిక్స్ చేస్తే ఫైనల్ మిక్చర్ టెంపరేచర్ ఎంత ఉంటుంది అంటాడు. సో చాలామంది అతి తెలివిగా ఆలోచించి T1 ఈజ్ ఈక్వల్స్ టు 40 అండ్ T2 ఈజ్ ఈక్వల్స్ టు 80, T1 + T2/2 వేసేస్తారు. లేదా ఇంకొంతమంది ఏం చేస్తారు, T1 + T2 టోటల్ టెంపరేచర్ అన్నాం కదా, ఫైనల్ టెంపరేచర్ ఏమవుద్ది, ఇది 40 ఉంది అది 80 ఉంది, దెన్ వాట్ వుడ్ బి ద రిజల్ట్, 40 + 80 120, వెంటనే 120 పెట్టేస్తారు. జస్ట్ ఇమాజిన్ దట్ మనం ఒక బకెట్లో హాట్ వాటర్ ఉంది, హాట్ వాటర్లో కోల్డ్ వాటర్ కలిపితే ఆ హాట్ వాటర్ టెంపరేచర్ ఏమవుతుంది, 120కి రైజ్ అవుతుందా ఇంకా డిక్రీజ్ అవుతుందా, isn't it, right? So obviously it decreases. At the same way we have taken a 40 degrees Celsius cooler body, right? దీనికి హాటర్ ఆబ్జెక్ట్ని సబ్స్టెన్స్ని యాడ్ చేస్తే వాట్ అబౌట్ ఇట్స్ టెంపరేచర్, ఆబ్వియస్లీ ఇట్ ఇంక్రీజెస్, బట్ we don't know how much it will be, right? So For this, first of all, we have to derive the equation. అర్థమైంది అనుకుంటా, I hope, right? అంటే hot the resultant temperature may not greater than 80 and may not less than 40. In between the value will be, right? So now here let me uh, derive an equation for it, because many people are confusing. If you once watch this video, if you understand this derivation, then you no need to depend upon anyone. You can solve any kind of problem based on this formula easily, right? So first let us think. We have taken a substance in one beaker which has mass m1 and which has temperature T1, and we have taken another beaker. Which has a mass m2 and which has temperature T2. And what we have done, we have mixed both of them, right? As we have mixed both of them, the resultant mass is, where m1 plus m2 is the resultant mass of those two substances, and the temperature is caps T. I cannot tell it is either T1 or T2 or T1 plus T2 like mass, right? So let me take the final temperature is T. Now I have to derive equation for it. First of all, I told you a principle of method of mixtures. What is that? Heat energy lost by the hotter body will be equal to heat energy gained by the cooler body, right? Now let's calculate the heat energy. Let me take that T1 is the highest temperature and T2 is cooler body, right? So now let me think that if it is hotter body T1 is, then what happens when you mix this with this, then it loses heat energy. So loss of heat energy will be equal to, as we know, formula Q is equals to Sm delta T, right? So here S in the sense specific heat of substance. So mass, this substance specific heat is S1 and the second substance specific heat is S2, right? Second one substance is specific heat is S2. So now here Q is equals to, formula Q is equals to Sm delta T. Sm delta T. So here specific heat of first substance and mass of the first substance. Here the first substance is losing heat energy. It means that the temperature decreases from T1 to T. This is the final temperature, right? So hotter body, obviously when you mix with cooler body, it loses heat energy. When the substance loses heat energy, its temperature decreases. So now here temperature definitely decreases to T1 to T. Now change in temperature will be equal to nothing but T1 minus T, isn't it? So that I'll write that in the place of Q is equals to Sm delta T. S is S1, mass is M1, and the delta T, change in temperature, is T1 minus T, right? So this formula gives you the loss of heat energy by the hotter body. In the same way, by using the same formula, we can calculate the heat energy gained by the cooler body, isn't it, right? So now here further the same formula, heat energy gained by the cooler body will be specific heat of cooler body and mass of the cooler body and change in temperature. This is less temperature T2, right? After mixing with hotter body, the T2 temperature rises to T. In this condition, the change in temperature will be what happens? Caps T minus T2, I mean T2, isn't it? So the change in temperature will be T minus T2. Clear? Now here we have to, it's time to apply the principle of method of mixture of right? We have to apply to know the final temperature. What we have, which principle we have to apply? The principle, the method of mixtures principle we have to apply. What is the method of principle? I mean, excuse me. Yeah. What's that? Before I have discussed about that, when you mix to objects, I mean when you touch two objects, then what happens? The heat energy lost by the hotter body will be equal to heat energy gained by the cooler body, isn't it? So here we have to apply the principle of method of mixtures, right? So what is that? Heat energy, let me write from here, heat energy lost by the hotter body will be equal to heat energy gained by the cooler body, right? So now heat energy lost by the hotter body means S1 M1 T1 minus T is equals to S2 M2 T minus T2, right? So now here multiple them, S1 M1 T1 minus S1 M1 T, that is equals to S2 M2 T minus S2 M2 T2, isn't it? So now here take what we want to find, we want to find the final temperature, right? So now take this minus M1 S1 M1 T2 that side and send this S2 M2 T2 this side. Then what happens? S1 M1 T1 plus S2 M2 T2, that is equals to S2 M2 T plus S1 M1 T, right? So now what I have to do is let me rub this, right? I'll do it from here again, right? Now what I'll do is I'll take common of this T. Here what happened? S1 M1 T1 plus S2 M2 T2 will be equal to T common this there. If I take T as a common, S2 M2 plus S1 M1, right? So what we want to find? We have to find final temperature, means capacity we have to find. So send this equation to this side. Here it is multiple, if we send this side it becomes a division, right? So S1 M1 T1 plus S2 M2 T2 by S1 M1 plus S2 M2. So by use this is equal to total temperature, right? By using this equation, whatever the problem they give like this, we can solve easily. So here if you observe carefully in our textbook, there will be formula which is like final temperature will be equal to M1 T1 plus M2 T2 by M1 plus M2, but they won't mention the S1 S2 values. Here this is the equation for any type of substance. You can mix any two substances not similar, right? You can mix them also. Further also you can use this. Actually in our textbook they'll give you problems like what happens if hot water is mixing with cool water. Here both are same substances, right? Mean the specific heat of the substance is same. So that what happens here, we can write S1 is equals to S2, right? If in one bowl we have taken hot water, another bowl we have taken cool water, and you mix them, means it tells that the specific heat of both substances will be equal, so that S1 is equals to S2 is equals to S. Then what happens here? S M1 T1 plus S M2 T2 by ikkada S undi, ikkada S undi, so we can take it as common, right? S common this same avutundi M1 plus M2, that is equals to T. So here paina kuda chudandi, ikkada S undi, ikkada S undi, so that we can take them as a common, right? Ikkada kuda S common this same undi M1 T1 plus M2 T2. Now S gets cancel, and finally you will get a final temperature T is equals to M1 T1 plus M2 T2 by M1 plus M2. So by using this formula you can find a final temperature of any given substance. Here this formula only for the similar substances. If they ask you two different substances at different temperatures, we have mixed them, at that time you have to use this formula. I think it's very clear. Yeah, in next video we will discuss some other problems from the same lesson. Thanking you all.